Projectile motion. Projectile is the name given to an object thrown with an angle with horizontal direction under the influence of gravity only. Object move in a vertical plane on a parabolic path and its motion known as projectile motion. We are going to analyze this motion with respect to time of flight, the time for which this projectile remains in the air. The next is the maximum height attained by this projectile, and the third one is the range. Range is the distance traveled by the projectile in horizontal direction before it hit the ground. To do that, we will represent this two-dimensional projectile motion in two independent motion in two perpendicular directions. In this case, as the direction of x-axis and the perpendicular direction of y-axis. The initial velocity in x direction is the component of this velocity in x direction, which is u cos theta, and the velocity in y direction or in vertical direction is the y component of its velocity, which is u sin theta. So here the given projectile motion can be represented by two independent motions. Remember, it's a two independent motions in x and y direction. So x direction motion is start with initial velocity u cos theta and y direction with u sin theta. So now let's analyze this motion in x and y direction. So first we will analyze this motion in vertical direction, which is y-axis. So here the initial velocity of the projectile in y direction is uy, which is given by u sin theta. The acceleration in y direction or vertical direction is the acceleration because of gravity. Since this is in downward direction, so we will take this as a negative. Now the maximum height attained by the projectile depend on its vertical motion only. So here distance or maximum distance or displacement covered in vertical direction is sy, which is equal to h. Now assume the time taken to reach this maximum height by the projectile is ty, and at this maximum height the vertical velocity of the projectile, which is vy, is equal to 0. Remember, at this point its horizontal velocity is not 0. So overall, at the highest point also the particle or the object is in motion. So to analyze the motion in vertical direction, we will use the motion equations with constant acceleration. Here the velocity at the highest point vy equal to initial velocity in y direction plus acceleration in y direction and the time to reach the highest point ty. So on putting these values, you will get u sin theta minus g ty. So ty is the time to reach the highest point is u sin theta divided by z. Okay. In projectile motion, the time of the flight or the total time of the flight is 2 times of ty. So here the time of the flight is 2u sin theta divided by z. Now we can find out the displacement, the maximum height attained by using formula vy square equal to uy square plus 2ay sy. So on putting values, this will be 0, this will be u square sin square theta minus 2zh. So this will give you the maximum height attained by the projectile, and this is equal to u square sin square theta by 2z. So this way, by analyzing the vertical motion of the projectile, we can find out the time of the flight t and the maximum height h attained by the projectile. Now let's analyze the horizontal motion to find out the projectile range r. In this case, the horizontal initial velocity is ux, which is equal to u cos theta. And since in horizontal motion there is no acceleration because the gravitational force on the projectile is always in downwards. Since this force is perpendicular to the horizontal motion, it does not affect the horizontal motion. So the horizontal velocity of the projectile remain constant as u cos theta. So here the projectile range is the distance traveled by the object in horizontal direction during the time of the flight, and the time of the flight t is 2u sine theta by z, which we have calculated from the analysis of vertical motion. So here in this case, the range r will be given by u cos theta, which is a constant speed, multiplied by the time of the flight, which is 2u sine theta by z. So we know this will be equal to 2u square sine theta cos theta by g. And from trigonometrical formula, we know that 2 sine theta cos theta is sine 2 theta. So range r can be written as u square sine 2 theta by z. So this way we have derived formula for maximum height attained, the time of the flight and the range of the flight. Now let's consider the situation in which we throw the ball in vertical direction. What does that mean? That means the theta here 90 degree. So when we throw a ball in vertical direction, it reaches to maximum height for given velocity. So in this case, the maximum height attained will be equal to u square by 2z, since sine 90 is equal to 1. Now next is the time of the flight. T is equal to 2u by z, and the range is equal to 0 because sine 2 theta means sine 180 and sine 180 values 0. From the derived formulas, we understand that for a given initial velocity, the maximum height, the time and the range of a projectile depends on theta, the angle of projection. Now, for a given initial projectile velocity, what should be the angle to achieve the maximum height? The height will be maximum when the angle of projection gives the sine theta value maximum, and sine theta value is maximum in case of angle 90 degree. Sine 90 is equal to 1, and in that case the maximum height achieved by the projectile is u square by 2z. Under the same conditions, the time of flight will also be maximum and equal to 2u by z. What about the angle of projection for the projectile to achieve the maximum range r? Here the sine is 2 theta. The range will be maximum when sine 2 theta will be equal to 1, and this value will be equal to 1 if the 2 theta is equal to 90 degree, or you can say theta is equal to 45 degree. So for a given initial velocity, if you want to throw a projectile for its maximum distance, then you have to throw it at 45 degree. Now let's do some problems to apply our understandings. The problem 1 is related to time of flight and projectile range. A soccer ball is kicked at angle of 45 degree off the horizontal surface with an initial velocity of 20 meters per second. How long will it remain in air and how far will it fall on the ground? So we have to find out the time of the flight and the range of the flight. So here the given information is angle of projection, which is theta equal to 45 degree. The other information is the initial projectile speed u is equal to 20 meters per second. And now we have to find out how long will it remain in the air. That means the time of the flight t, and how far it will fall on the ground means range r. So time can be calculated by analyzing the vertical motion and the time of the flight t, which we have calculated in our initial part of this video, which is equal to 2u sine theta by z. Here theta is an angle of 45 degrees, so we can write down 2 into u is 20 sine 45 divided by g value we take as a 10 meter per second square, and this give you t equal to 2 into 20 multiplied by 1 by root 2 here. This is 10, so you can cancel out 2, so this become 2 root 2 second. So the ball will remain 2 root 2 seconds in the air. So during this time it will travel horizontally. So range of the soccer ball is given by the constant velocity in horizontal direction, which is u cos theta multiplied by this time period or time of the flight, which is 2 root 2. Here the u is 20 cos 45 multiplied by 2 root 2, and cos 45 is 1 by root 2. That means this become 40 meter. So the range of the soccer will be 40 meter, or the ball will fall at 40 meter distance from its initial point. Problem 2. This problem is related to angle of projection and related projectile range. A boy throws a stone at angle 30 degree from horizontal to hit a target at a distance of 100 meter. We have to find out the initial velocity of projection u. Now for the same velocity, what is the other angle which will have the same range 100 meter? So we have to find out the theta from horizontal or from the vertical y-axis as shown in this figure. Now here the given information is the angle of projection theta is equal to 30 degree. Range of the projectile is 100 meter. And we have to find out the initial projectile velocity. The first thing. The other thing is we have to find out the angle of projection for which, if the projectile is projected with the same initial speed u, it will cover the same range or it will fall at the same point. The range of the projectile r can be given as u square sine 2 theta by z. So we can say u will be equal to rz divided by sine 2 theta. So this will be equal to 100, and we take a value of g as 10, and sine 2 theta means sine 60, and sine 60 value is root 3 by 2, okay, and square root of 8. So this will be 2000 divided by root 3 square root meter per second. Now the second part of the question is, what is the angle, other angle, if we project the same projectile with the same initial velocity u, it will fall at the same distance. So for this we need to know that the sine r is dependent on theta as 2 theta. So we know that the sine theta is equal to sine 180 minus theta. So we can write down sine 2 theta as equal to sine 290 minus theta, right? And this become sine 180 minus 2 theta, and which is equal to sine 2 theta. So it means if we project the projectile or the object at angle 90 minus theta, it will also reach to the same distance from its starting point. So another angle to project is 90 minus theta. So in this case 90 minus 30. So it will be 60 degree from horizontal, or it will be 30 degree from vertical. So we can conclude that a projectile range will remain the same for given initial velocity of an object if the angle of projections are complementary angles. Now let's check out the problem 3. A projectile has the same range r when the maximum height attained by it is either h1 or h2. And we have to find out the relation between r, h1 and h2. We know that a projectile can have the same range if the object is projected at complementary angles like theta 1 and theta 2, and theta 1 theta 2 should be or must be equal to 90. In that case, the theta 2 will be equal to 90 minus theta 1. So if the object is projected at angle theta 1 and here angle theta 2, then we can write down the h1 will be equal to u square sine square theta 1 divided by 2z, and h2 can be written as u square sine square 90 minus theta 1 divided by 2z, right? So this will become u square cos square theta 1 divided by 2z, right? So now if we multiply this h1 with h2, we will get u raised to power 4, and then you get sine square theta 1 cos square theta 1 divided by 4z square. Now let's multiply the numerator and denominator with 4. So you will get u4 4 sine square theta 1 cos square theta 1 divided by 4 into 4z square. Now we know that 2 sine theta 1 cos theta 1 can be written as sine 2 theta 1. So this whole expression can be written as u raised to power 4 sine square 2 theta 1 divided by 16z square. The range of the projectile is given by u square sine 2 theta by z. Okay, so here if we see this expression, we can say u4 sine square 2 theta 1 by z square, nothing but the r square. So this can be written as r square by 16, and by this relation we can say r equal to 4 root h1 h2, and that is the relation between r, h1 and h2. And that's all we have for today's session. I hope you would have enjoyed this. If you think you have learned something new today, then please click like button and subscribe us for similar type of videos. Thank you for watching. See you next time. Bye.